Hello, Internet. If you're new to data analytics or artificial intelligence, but you're interested to learn more, you want to gain some first impressions, welcome. This is the video for you. Now, at first, we have to make sure that the scene is set up. We have data, and I want to be specific. Data is the most important part in this. Because you will have to collect data from all over sources. You will apply some artificial intelligence. You will apply some machine learning. You will apply deep learning. You will use some TensorFlow frameworks, some PyTorch frameworks to generate insights from your data, run those models, but the result is you will get new data. And this new data will be configured in a way that provides new insights for you. Generate or augment insights for human being, one of the main tasks of artificial intelligence. But of course, if you train an artificial intelligence model, you will be able to feed new data to the model, and the data will provide you with the output, with the answer that it learned. So you see, you have data as an input, you have some processing of the data, let's say machine learning, and you will get the output, also data. So data is all you have, data is all you need. But let's start a little bit more specific, because imagine it's a battlefield and you are entering this battlefield and you have to choose your weapon. So what you want to choose? You want to be able to just have a one cloud option, you are specialized on one thing and one thing only, or do you want to be able to have a variety of weapons? Do you want to learn quite a lot of different strategies? So how to start, where to start? Have a look at this diagram. As you can see here, on the right side we have data science in yellow and machine learning in kind of pink. So these are the two pipelines that you always have. A data pipeline, and you crunch the data, you do something with the data. It's an input, you have a data pipeline, you calculate something, and you get data out. But you want to be able to enter the area of data science, and you want to be able to have an idea about machine learning and the algorithms over there. So which technology platform do you choose? Now, for machine learning, it's quite easy, because right above machine learning on the right-hand side, you see there's TensorFlow in blue and PyTorch, one of the most common machine learning frameworks, I would say. They are really mighty. They have a constant development in the code. And what you can do today, from deep learning to graph learning, is amazing with both of them. And I would recommend you choose a platform where you can run TensorFlow and PyTorch. You do not have to choose, both are possible. And as you already see here, we are in the area of the data scientist on the right-hand side. But this is no longer really true, because what used to be data engineering, or maybe even in the 1980s, I would say a data analyst, that you have your structured data, that you have clearly defined data that have one form and one form only. And you have data warehouses where everything is very strict, everything is regulated. This almost does not exist anymore. Yes, of course, you can have your Amazon Redshift data warehousing or whatsoever, whatever platform you choose, IBM or whatever, BigQuery from Google. And SAP is a typical company operating still in this area, but the area of data engineering, data streaming, batch is more or less coming together all to data science, and you should be able to have a technology platform to support all of these new developments. And of course, you should have a platform that is not only one cloud and one cloud only. You should have a modular approach, that you can have a multi-cloud approach, that you are not limited to what vendor or one provider, because imagine if this provider stops, then what you do. So if we say We only, the idea that you only have structured data for business intelligence or data warehousing to be a data analyst, this is not true. And you say, okay, I want to have a broader view, a broader knowledge. You see here that in data engineering, you have structured data, semi-structured data, and completely unstructured data. And you are familiar that this is, I don't know, in the 2000s, this was the data lake. You dumped all your data in a data lake, and you had multiple copies. Whenever you needed something, you just filtered it out with a pipeline, and you had some filter and to finally structure the data, and then you pumped it back into your data warehousing. But you lost a lot of data. The quality was not good. You had multiple elements in your data lake. And of course, if you had some streaming, some continuous data coming in, flowing in, you have to make sure, oh, do I already have this data? Does it modify existing data? Where does it add? Where does it fit? How can I merge this data? And all this developed so that in 2021, you see structured, semi-structured, and unstructured data are coming together in, if you want, Data Lake 2.0, it's called Delta Lake, where the file format is a parquet format. You have some ACID transactions, and this is the very nice thing, you have a form of data that you can use immediately for data science or machine learning. This means Delta Lake, provided, for example, by Databricks, is for your data one of the evolutionary steps I personally would recommend. I'm not sponsored by them. They don't even know that I exist, but I can tell you this is really, really interesting evolvement from a data lake into a Delta Lake. Now, of course, you already heard that I was talking about clouds, different clouds. And I can tell you, at the weekend, I want to take some work home with me. I have a little hut somewhere in the forest. I have my laptop, and I have no internet connection to the cloud when I'm sitting somewhere in the forest. So I don't want to be only cloud-based. I want to have the ability to run my systems on my local notebook, that wherever I am, wherever I'm traveling, on the way to work, I want to be able to operate, to test it out, to experiment at home, maybe some algorithms. So I want a platform that is not only cloud-based, but I can have a local copy and I can work on a local machine. Another complexity level would be, do you have just one node or a multi-node? Or if you have a CPU with, I don't know, 10, 20, 128 cores, can you utilize all cores for the calculation? Well, like me, for example, I have no NVIDIA graphic processing unit, so I cannot take advantage of CUDA cores. I have an AMD graphics card, so I'm solemnly based on CPU performance, but I have quite a lot of CPU cores, so can I be able to operate with my local system and do this highly parallel process? And the answer is yes to a lot of those things. So as you can see here, with data engineering, I marked Apache Spark. It's an open source, and also with the second column from the left, if you have data engineering's Hadoop, Amazon EMR, Apache Airflow, Apache Spark. So you see more or less Spark as a platform, a technology that is also based on Python, PySpark, where, or if you want to go with Scala, no problem, where you can apply your knowledge from a simple complexity machine to a higher node machine, to a Spark cluster, for example. It's highly scalable. So is there a platform where you say, hey, can I start on a single node, simple, on a platform I can use for data science, for machine learning? I can run my TensorFlow application, my PyTorch research. Is there something that then scales up for a multi-node Spark cluster or multi-node cluster with Azure or in Google Cloud or in AWS, whatever? Yes, there is a solution. And to make the long story short, I would recommend you start with a Jupyter Notebook. A Jupyter Notebook is kind of a standard currently, I would say, in data science and machine learning. And it is extremely flexible. You can run a lot of libraries. I use, for example, Python. Maybe if you're coming from data science, you are more inclined to R or whatever. No problem at all. Jupyter Notebook is a really broad platform. You can run you can experiment. You can have your first steps there. You can run your system. You can play around with different configuration. It's highly scalable in Apache Spark. You also have Jupyter Notebooks. You just have, I don't know, then 10,000 CPUs and 1,000 GPUs or tensor processing units or whatsoever. No problem at all. So therefore, if you're fresh to the system of data science, of machine learning, and you say, hey, where should I start? What is my weapon of choice? I would say Jupyter Notebooks. If you start with Jupyter Notebooks, if you become familiar, if you understand how to integrate different Python libraries, different Python frameworks like TensorFlow or PyTorch for machine learning, you have a perfect open source platform if you want to jump to Apache Spark, if you want to imply the new data ideas, not just from Data Lake, but also from Delta Lake, if you have some ACID transactions, if you want to run some parquet files, the file format is parquet. If you want to have a system that enables you to do all of this on one platform, on a single node machine, on your laptop, on my laptop here at home, or on the cloud, if you go to your company or wherever you are currently, this is a pandemic, if you're working from home, no problem. Jupyter Notebook, I think, is a very, very solid start from you if you want to enter the world of data science and machine learning. And this is it for this video. I have a video coming up, and maybe it is already on the top right corner that you can click on it, where it shows you how to install a Jupyter Notebook, how to set it up, how to be up and running, that you can start programming. You can have your first Python program or your first R program or whatever language you choose on a cloud, on a cluster, on your local machine, whatever you have. Even in the case like I do, I only have a multi-core CPU. I can run all my applications. Of course, only a subset of the data. I just have, I don't know, if you have a Panda data frame with millions of entries, I just take 10,000 of entries. I just want to experiment on a local machine. I want to see if my algorithms work out, if there are some problems, what are the problems, what error messages I can get back. I want to understand, I want to play, I want to become better with this. And I can tell you, Jupyter Notebooks really have been a very solid basis for me. And I would recommend you start with a Jupyter Notebook when you enter the world of data and artificial intelligence. Thank you for listening, and I see you in the next video.